What up, YouTube? It's your boy Nick Wan. I'm here with a YouTube tutorial on how to create your first NFL analytics predictive model. We're going to be predicting touchdowns. It's going to be really easy. I'm going to walk you all through it. And if you want to follow me along, you can follow not just this video, but you can open it up and the GitHub link. It's probably down here somewhere. And if you don't want to use the GitHub link, you just want to hear my voice and hear me talk about it, you could do this also. Conceptually, you could bring this over into R, you could bring this over into Rust, you could bring this over into Julia, you could bring this over into wherever. I'm sure it's going to work perfectly there too. So let's get started. You can see here, we're starting off with where the data is. You can actually go to this link right here and download the data. There are a few different ways to download this data. In my opinion, if you just download the data from this website, you could click it, you could set up some sort of git pull for the data, whatever you want to do. I'm not going to go over that in this tutorial, so I'm just going to assume you have this data somewhere in your Google Drive. So I'm going to be using Collab for this. And if you're not using Collab, that's okay. This can work in your Jupyter Lab. You could do this in Jupyter. You could do this in VS Code, whatever you want to do this in. So long as you have your paths right and you know what I'm talking about, where you got to go retrieve your data, then you should be fine. Some packages that we're going to load in initially, because I'm working in Google Colab, I'm pulling my data out of my Google Drive. So I'm going to need OS to access my operating system. That way I could go and locate where my files are and then bring them in. We're going to be using pandas and NumPy. These are packages that allow you to bring in data in a lot of different formats. We're using CSVs today, so we're going to be using a ton of pandas. We're going to be using Matplotlib and Seaborn for our data visualization. This will help us just keep our head on straight when we're looking at different correlations or different trends in the data once we have our data loaded in. So when we're opening up our data, what I'm doing is I want to navigate to my project directory here. My project directory in this case is in my Google Drive. If you are using Google Drive, drive/my drive is how you get there. If you're getting some sort of weird error that says like there's no location, you might want to check to see if you've mounted your drive, and that's a button right here. This button right here will say mount drive. If it has an X through it, it means it's mounted already. I'm going to be looking at my Google Drive, and I actually want to explore my drive. So I'm going to type in project directory and a few different layers of folders here. This is just like navigating something on your desktop, navigating something on your local computer. This is just going to a folder. And I'm listing out these different folders. You can see that each of these folders here, we have over 20 seasons of data in all of these different folders. Inside one of these folders, if we go to a single seasons folder, you'll see that we actually have play-by-play data. So in this case, we actually went into this season equals 1999 folder. And inside that folder, I'm finding a play-by-play 1999 CSV. So that's this comma separated value. This is just tabular data. This is data that we see that you could load into Excel. You could load this into MATLAB. You could load this into SPSS. You could also load this here in Python in Pandas. For our purposes, we're just going to be using 3 years of data, not all 20 bajillion years of data. We're just going to use 3 years, 2019, 2020, and 2021. By the way, if you know a better way to write this list comprehension, type it down there in the comments section. I don't know a better way to search for individual strings like this. There's probably a better way, but I kind of shotgunned this tutorial, so I don't really know off the top of my head what the best way is. So if you have a better way, just let me know in the comments. When I'm loading my files, the first thing I need to do is I need to actually say what the entire path is. And remember, our path is in Google Drive, so we're using drive, my drive. That's accessing my Google Drive. I have a bunch of different folders, a bunch of different parameters for my folders here, a bunch of different parent folders for where my data lives, and then I access my data. But I'm not going to know just based off the file name where my data is. I'm going to need the full path. So I put in all the full path here. That's what this data files does. Once you have your path to your files, you're going to open them now. In this case, the way we open them, we have to do a few different steps. The first one is you have to initialize your data frame. The reason you do that is because your data doesn't know where to load into, right? If you just open a data frame up, it's going to open into a data frame, but it doesn't know that you're trying to append a bunch of stuff to that. So the easiest way to do this is to just initialize a data frame first. And then we're going to loop through our files, and then we're just going to append or add or concatenate, whatever you want to call it. It's append in pandas. We're going to append or join or union to the bottom of this data frame. So for each CSV we read in, we're just going to add that to the bottom of our data frame. And then that's what this does. So we append and we pump out this new data frame. But because each CSV that comes out has their own index, like 0 to, let's say, 30,000, we don't want repeats in the row names or in the index numbers. So we're gonna reset that index right here. If you don't know why that's happening, or if you don't understand like why that's important stuff, that's okay. You're not gonna really run into any issues with this in this tutorial. But in other things, you might have issues with duplicate indices. And so this is just an easy way to avoid that once you load in all your data. I also print my data frame just to see how much data we've loaded in. In this case, for 3 seasons of data, we're looking at just shy of 150,000 rows. So if you're trying to do this in Excel, or you're trying to do this in a program that might not support a lot of rows like this, then you might have a lot of slowness. When you're doing this in Python, you're going to find out that this is actually pretty quick to load in all your data and also work your way through the data as we're about to do and as we explore the data. So once the data is loaded in, you could actually explore a little. I look at the head or the top 10 rows. You can see the top 10 rows that we've loaded in here. I also look at just a random sample of 5 rows. Sometimes the top 10 might be a little misleading. I do like to look at a random sample of rows just to get a better idea of these values, if we have any missing data or if some data looks different than other rows. But in this case, it all looks pretty good. And then at the same time, I also want to see how many columns we're working with. And in this case, as the shape of the data set says, and down here for the head and for the samples say, there's 372 columns, and that's a lot of columns. So if you're overwhelmed by the amount of data that we're loading in, don't worry about that, because in the next section, we're going to talk a little more about a smaller set of data that we're going to be using related specifically to quarterbacks. Okay, so if you made it this far, we've loaded in a bunch of data. It's all in our pandas data frame. Now we're just going to explore our data and see what stuff correlates with touchdowns. So the project that I'm thinking we should do is just see how many touchdowns is a quarterback going to throw. I want to take a look at a few different things about a quarterback, but the first thing we got to do, since this is play-by-play data, it's not over the course of a season data, we're going to need to aggregate or group by our data. So we're going to take a bunch of different quarterback features, in this case, the season, who the player is, who the passer is, the quarterback is, and some of the statistics that we care about. So passing, whether they were intercepted or sacked, the amount of yards gained when they threw the ball, and then, of course, how many touchdowns they threw. If you're not familiar with group by statements, there's probably a great tutorial out there that talks all about group bys. In this case, if you are a little familiar, we're grouping by the season and the player who, in this case, the quarterback. So if you can imagine in your head, we're taking the season and the quarterback, and we're just adding together all these different statistics. In this case, how many passes they threw in the season, how many touchdowns a quarterback threw in the season, etc. You can see that group by statement right here. All we're doing is taking those quarterback features we set in the list up here, and we're also grouping by these group by features we set above as well. You can see right here, this is a sum. We're aggregating, we're summing over each of these seasons. When I'm done with that, I also take a look at the sample. So I just, again, print out a random sample of 10. And I can see how many touchdowns a particular quarterback threw. Like here, Nate Mullins in 2020 threw 15 touchdowns, whereas Matt Barkley threw 1 touchdown. So after we created this data frame, what I want to know is what correlates with touchdowns, because at the end of this, we want to make some sort of prediction on touchdowns. And we could see that over the course of 1 season, yards gained predicts touchdowns. The amount of completed passes predicts touchdowns. The amount of passes thrown in general predicts touchdowns. And some other things predicts touchdowns, which are a little interesting, but it makes sense if you think about it. The number of interceptions thrown correlates with touchdowns, and also the number of sacks received predicts touchdowns. And this kind of makes sense because the more pass attempts you're throwing, the more likely you're going to throw interceptions. And also, the more sacks you have on you, the more likely you're the primary quarterback. You're not just like a random person throwing a trick play. So you're most likely a quarterback who's trying to make passes. And of course, the more sacks you have, it's not good, but it is maybe an indication that you're the primary quarterback. Okay, so that's all interesting, but that's if we know what happened in 1 season already. So for instance, if we know the amount of yards gained in the season, then we could predict touchdowns pretty well. But what we want to know is the future. We want to know if what a player did last season, does that correlate with what they're going to do the next season? So we're looking for year-over-year trends. So in order to get that information, we're going to have to do one more manipulation of our data. We're going to take our data set, we're going to copy our data set we just created. The next thing we're going to do is we're going to take that season variable that's in there and we're going to add 1 to it. And the reason we do that is because we're treating our information for 1 season as the previous season's information. And that's going to make sense when we join, if that doesn't make sense right now. So now we're going to create a new data frame. We're going to merge this data set which has season plus 1. We're going to merge that on season and passer. So this is just our identifying information for the quarterback season. We're going to label our suffixes. And what's happening here is this data set is going to get no suffix. And the data set that I'm merging, this new data set, this is the previous season's data, right? So when we merge on season, it's looking for this column. And because the years match, and this is offset by 1 year, all of this information in this copied data frame here is actually from the previous season. So we're calling this _prev, or this should indicate what the previous season is. And we're going to use a left join instead of an inner join, because the left join is going to allow us to also see seasons where we didn't have previous data or seasons where we don't have predictions for yet. So if we do another sample of our new data frame, you'll see that we have all the information that we typically had in that original data set with pass, complete pass, interception, sacks, yards gained, and touchdown. But now we see a bunch of columns after it which has the suffix prev, or previous season. So what the player did in the season last. And sometimes you're going to get nans or null values because we only brought in 2019, 2020, and 2021. So whenever you see 2019, since we don't have 2018 data, it's going to say nan. But for a season like Mitch Trubisky, in 2020, we actually do have data from Mitch Trubisky in the previous season. So you can see here, Mitch Trubisky threw 19 touchdowns, and in the season before that, in 2019, he threw 17 touchdowns. Okay, so now that we have a new data frame with previous season information, we're going to be able to actually look at year-to-year correlation. That's to say, did the thing in the previous season help predict the touchdowns for the following season? And you can see that there's actually, it's not as clean as the correlations we saw before, but there is correlations here. So for instance, the amount of touchdowns that you threw the previous season does have some correlation with the touchdowns you're going to throw in the next season. The yards gained in the previous season does correlate with touchdowns. You can see that with completed pass, the amount of passes you threw the last season. And you can see some weaker correlations for interceptions here. Whereas in our previous correlation, we saw it was like pretty strongly correlated with touchdowns. When we're talking about interceptions through the year before, that doesn't correlate with touchdowns that well. And then we could also see sacks do have relatively weak, but there is some correlation here for sacks as well. All right, so if you made it this far, we've loaded in our data. We've taken an exploratory look at our data. We've joined and made some new information, so our data can now look at year-to-year correlations. We've explored year-to-year correlations. Now we're going to make our predictive model, our machine learning model, and this is how we're going to do it. First, we're going to bring in some new packages. The new packages we're going to load in are from scikit-learn and scipy. These are things that you should already have if you're using, say, the Anaconda distribution, or if you're using something like Collab, like what I'm using. If you have to install this, feel free to install it. It's just a pip install. Or if you're using Conda, you could probably Conda install this stuff. So we'll take a brief look at what our data set looks like that we're going to use for our model. And again, we're trying to predict touchdowns. And we're going to use previous season information to predict the next season's worth of touchdowns. And so our data frame is set up for that. We see that we have touchdowns here, and we have a bunch of columns as the underscore prev, which is indicating the previous season performance. We're going to use something called a train test split. So if you're not familiar with a train test split is, Code Basics does have a pretty good tutorial and theory on what a train test split is. This is a really strong, important principle of machine learning. TLDR, you don't want to test on the things you train on because you're going to get overfit models. So if you're not familiar with it, I would say brush up on your machine learning a little and come back to this when you do understand a little about train test splitting. All right, so again, we're going to use previous year performance to predict touchdowns. And so we have our feature set here. These are all the previous performance statistics that quarterbacks had. And we are trying to target, or we're trying to predict touchdowns. Sometimes you see this as Y and X. Sometimes you see this in different ways. I'm using feature and target. You might see this in different stylings or formats on Kaggle or on other Jupyter notebooks. But I'm using features and targets here. We're going to create a subset of data called model data. And that's because not all of our features and targets have values, right? Remember, when people have 2019 data, we're going to have a lot of null values for the previous data because we didn't bring in 2018. So we're going to try to eliminate all of our values that don't have numbers or they're null values. We're going to take that out of all of our data set, and that's what this drop NA does. So we're going to drop all the nulls in our data set, and the subset is anything that's in our feature set and any of our targets that are nulls. So we're going to set up our train data set, and that's looking at our 2020 data set. And so we're just going to say, let's look at our season, and all the seasons that start with 2020, we're going to use that as our training data. And then for our test data, we're going to look at only 2021. So we're training on 2020 data. So basically we're saying the previous season in 2019, what did someone do in 2020? And then in our test data, we're going to give them the 2020 data, the previous year of 2021. The 2020 data, what did they do in 2020? How is their performance going to be in 2021? The next part is probably the easiest part about machine learning. A lot of people think like, oh, this must take a lot of coding to just begin machine learning. It is one line, and here it is. Model equals linear regression. That's all you need to do to initialize your first machine learning model. The next thing you want to do is you want to fit or train your model on data. And in this case, the data that we're training on is that trained data set that we specified before. That's that 2020 data. And the features that we're going to train on are the features that we also defined previously here. This is all the previous season statistics from quarterbacks. And our target is touchdowns for the current season that we're looking at. So in this case, 2020 touchdowns. We're going to use 2019 data to predict 2020 touchdowns. This next part is the prediction. This is kind of the exciting part for machine learning. You're going to take your test data that your model hasn't seen before. It wasn't trained on this data. And we're going to use the same features, so previous season features, but remember, the model hasn't seen 2020 data. So it just knows about 2019, and it's predicted 2020. So now we're going to see if this holds up for the next season in 2021. We're going to use our test data, we're going to use 2020 previous performance to predict 2021 performance, and we're going to put that into a variable called preds, or predictions. Whenever you create predictions, something that's really safe to do, especially if you're using pandas for all of your analysis, is to make sure you're setting your index back onto your predictions. So when these predictions come out originally, they're going to come out as a NumPy array. And that NumPy array doesn't have any of your pandas index values on it. All right. So an easy way to kind of scramble up your predictions in a way that you might not want to is if you're switching between something that's indexless versus something that does have an inferred index. So a really safe thing that I do all the time is I always take my predictions, I put them into a series, and I set my index. If that's a little confusing, I do recommend a tutorial on pandas data frames. I have one on my channel. You could take a look at that on Sliced Basics. After you make your predictions, and once you set your index to your pandas series here, you could actually just set that equal to your test data set. And you don't need a join, you don't need a merge statement. It's just going to implicitly find the index values, and it's going to insert those values into each of those rows. Once we have trained our model, once we've predicted our model, once we've sent that model predictions, set it back to our test data set, we're functionally done with all the machine learning. All we got to do now is the statistics part. Statistics for linear regression are pretty straightforward. You're going to be using two statistics for the most part. There's a lot of statistics out there you can use for linear regressions or for any machine learning model metrics that you want to choose. There's a ton of them out there. But for linear regression, two that people commonly use is root mean square error and R squared, which is just a Pearson R squared. So the root mean squared error is mean square error, and you take the square root of it, or you can raise it to the 0.5. That gets like root mean squared error, and what we want to see is a really low number for that. For R squared, we're taking Pearson R in this case. You could use Spearman R if you think your model is non-parametric, but if you don't know what either of those terms mean, then I do suggest taking a look at parametric and non-parametric statistics. If you don't care about what this means, if you're like, I'm good, Pearson R is typically a fine choice for these problems. So Pearson R in this case, we're going to take our actuals and we're looking at our predicteds, and we're going to square that. We're going to raise that to a 2. And so we're going to have our RMSE and we're going to have an R squared. And we're just going to print those responses. So RMSE in here is 8.35. Roughly, we're talking about a plus or minus of 8 touchdowns, which sounds kind of big, especially if you're trying to win a fantasy league or something. This is probably too much error, but this is a pretty simple model. So if you're trying to improve the model with different features or learning from more history instead of just 3 seasons, there is 20 plus seasons of data out there to train on. You could probably make this model a lot more errorless or lossless in this case. So root mean square error is a measure of how much loss there is. And then R squared, in this case, this is explain variance. So we are explaining 70% of the variance with the features that we included in this model, which is really good. Usually, if you're able to explain 70% of a variance in any problem, you're really on to some strong signal there. If we want to visualize our predictions and how they actually look compared to the actuals, this is what the graph looks like. The actual touchdowns are the x-axis and the predictions are the y-axis. And you can see that it actually lines up pretty well, even though there is pretty strong deviations here. Like we're saying one guy's supposed to throw 30 touchdowns and he threw less than 20 touchdowns. And other times where we're saying someone's going to throw 25 touchdowns, but they ended up throwing like nearly 60 touchdowns. For the most part, we're on the line. Some of these are right on this line, which indicates some of the quarterbacks we actually guessed pretty well. And if we take a look at the top 10 quarterbacks in terms of the touchdowns they threw, we can actually see what their predictions looked like here. So you can see here, Matt Stafford, that was this prediction here where we only predicted 28 touchdowns. He ended up throwing 54 touchdowns this season. And so that was pretty off. But here's Pat Mahomes, where we predicted him to throw about 48 touchdowns, and he ended up throwing 52 touchdowns. So that would be this one right here, where we're saying 48, and he ended up throwing 52. So a lot of these do get pretty close. Some of them are pretty far off. But overall, for our first simple predictive linear model, we did pretty good. So we used a really simple set of features from the previous performance of last year to predict the following season's touchdown totals. And we ended up having a decent model. Again, you could improve this model in a million different ways. You could use different features. You could use more data. You could use different modeling techniques like random forest or gradient boosted regressors. You could even use completely different things that we aren't even showing in this tutorial, like different ways to set up different priors if you're going to use a Bayesian technique, or different assumptions that you want to make in terms of how you hyperparameter tune through your model. Whatever you do, you could definitely beat this model. I'm interested to see how close people can get to these numbers. If you can beat me in RMSE or R squared, I would be just list what you got below, and if you have code, post it so I could verify that's true. You know, no lying in the comments section. All right, no lying in YouTube comment sections. Thanks for hanging out with me through that tutorial. If you liked that content and if you liked hanging out with me in my chat tonight, then please like, subscribe, all that good YouTube stuff. But if you really want to hang out with us and party, come check us out over on Twitch. That's twitch.tv/nickwan_datascience. The link's all down below there. Also down below, you can find the code to this tutorial. It's on GitHub, and you could also rip a clone of this notebook from Collab, especially if you're using something like NFL Fast R, which is what we got this data from. You can absolutely get the data and have it in the exact same structure. You could find that code down below.